Okay, so now we know two methods of describing our function, which is the y method, where we just use y equals to whatever our function is. Here it was x times 2. And the second is the f method, where we use f instead of y and just say whatever the function is. Here it's x times 2. Well, the third one is kind of special. Well, instead of using one variable, well, which you can see here in this case of y and f, it uses two variables. The method is fx method. There's f and then you write x in the parentheses. The f stands for function. It's a function. But here, whatever's inside the parentheses, that shows what is the input of the function. Right? Instead of conveying just one thing, like y and f here, that it is a function, this conveys two things, that it is a function and the variable inside the parentheses is our input. As you can see here in this case, our input is indeed x. If our input was, let's say, a instead of x, then we would have write a here instead of x, because the input was a then. But here it is s, so x. So we will use fx to describe our function. And the fx method is the same as this too, just with one more thing. We can simply say that fx equals x times 2. Right? The x times 2 does not change, since that's what the function is doing to the input. It is multiplying it by 2, so it doesn't change. All that changes is the left hand side. Here it was y, here it was f, and here it's fx, since the input is x, right? And in this method also, we can put any values of our input or any values of our x and expect a corresponding output. But there's one more step here. What step? Well, let's see. At x equals 1, my fx, I cannot write fx now, as if I write fx, I'm saying that the function with input of x. But I'm not using x as input anymore. I'm using 1 as input, right? So I have to write a function in terms of 1 times 2, or in terms of 1 in place of x. I have to change this x with 1, since x equals 1. But here I said the input is x, and then I'm using 1 as my input. That doesn't make sense. So I have to write 1 here as well. I have to say f at input of 1 will be equal to 1 times 2, right? Since f at input of x was x times 2, so f at input of 1 will be 1 times 2. And I can further find the value of f at 1, which will be 2, right? F at input of 1 gives me an output of 2. That's all this is saying. And this is very, very efficient, since I don't have to write this line now. Notice, instead of writing x equals 2, I can simply write f at 2. And can replace my x here with a 2. Since all this is saying, all this here is saying is function with input of 2. And my function here is x times 2. And if I put input of 2 here, it will be 2 times 2. So I don't have to write x equals 1, x equals 2 anymore. I can just say f at input of 2 will be 2 times 2. That reduces one more step. Since here in the f method, you had to write x equals 1, and then you have to write f equals 1 times 2. Here you did it too, x equals 300, and then proceed to find f equals 300 times 2. In y method as well, you had to write x equals 1 to find y equals 1 times 2. And you had to write x equals 100 to find y equals 100 times 2. But here, you won't have to write here. You don't have to write it here. You can just erase this thing and say f at 1 equals 1 times 2, f at 2 equals 2 times 2, and you can do that to any number. You can say f at, let's say, 1000 will be equal to, instead of x, you write 1000, and it will be 1000 times 2, or f at 1000 will be 2000. That's our 3 ways of describing a function. This way is pretty much used more than the other 2 ways, as it gives you an advantage. You don't have to write x equals 1, x equals 2, or x equals 1000 anymore. You can just write f at 1, f at 2, or f at 1000, which just says function with input of 1, function with input of 2, function with input of 1000. Now that you know 3 ways, let's conclude it. Let's summarize it. Now, in summary, we can say that we learned 3 ways of writing a function, which was f of x method, which says function with an input of x. Function, which is the f here, and with an input of x in the parentheses here, will be x times 2, which was our function, right? The second way was f equals x times 2. Instead of f of x, instead of writing this here, instead of saying that my function with an input, I just say my function and write x equals the value which I'm assuming. I do one more step. Instead of writing the input in parentheses, I do one more step and describe it in an equation. I can say x equals 1, x equals 2, and proceed to find it. And here I can just say f at 1, f at 2, and f at 3. Right? And here the third method is the same as the second, but instead of f, I use a y. That's the same thing. And in all the cases, the left hand side says function, and the right hand side has an input, which is my x, and times 2, which was the mathematical operation I was given in that question. One more thing to know is that I can use any of this form of expressing a function. It does not matter. The f of x, the f, or the y, they mean the same thing. They can be interchanged at any point of the question. For example, let's say I was given fx equals x plus 5, and I didn't feel comfortable with f of x, and I wanted it to be f equals x plus 5. I'll change it to f equals x plus 5. At any point you can change from this to this, f equals x plus 5. No one's gonna stop you. You can even change it to y equals x plus 5, and it will make sense. You can go from f of x to f to y at any point, and it will still mean the same thing. Your function will still be the same. Alright, now that you know how to describe a function, let's take one more example. Let's try expressing a function, and while doing so, we'll also learn one more thing. We're going to learn about independent and dependent variables, which is a pretty neat topic, and you'll enjoy it so much.